We are going to graph this rational function r of x equals x squared minus 3x minus 4 over 2x squared plus 4x. Now let's see if we can simplify it before we start. The only reason we would work with it unsimplified is if we were looking for the domain. After that, we would simplify it to find everything else that we needed. So r of x in its factored form, we're going to factor it by guessing. The top is x plus 1 times x minus 4. The bottom, we pull out a common factor of 2x. So it's 2 times x plus 2. Now we're going to find the x-intercept. The x-intercept is found by letting the numerator equal 0, because we're going to let y equal 0, so the whole fraction equals 0, but a fraction never equals 0 unless the numerator is equal to 0. So that means x plus 1 has to be equal to 0, the numerator, and the other factor in the numerator, x minus 4, has to be equal to 0. This will give us the x equal negative 1. This will give us the x equal positive 4. So our x-intercept will be negative 1, 0, and our other x-intercept will be 4, 0. Okay, so we know where the graph crosses the x-axis. Let's go ahead and find the vertical asymptotes now. It's a good time to do that. They are the zeros of the bottom, the denominator. Okay, so we're going to set the bottom in its factored form equal to 0. 2x equals 0 together with x plus 2 equals 0. And that's going to give us x equals 0 for the vertical. Now remember, this is the equation of a vertical line. That's our vertical asymptote. And here we're going to get x equal negative 2. And again, it's not a number, x equal negative 2. It's the equation of a vertical line, our vertical asymptote. Next, we're going to find our y-intercept. Good time to do that. We do that by letting x equal 0, and it's probably best to work with the original function that we had at the very top. So we got y equals 0 minus 0 minus 4 over 0 plus 0. Oh, wait a minute, that's undefined. So if we tried to find our y-intercept and we ended up with undefined, what does that tell us? It tells us there are no y-intercepts. No y-intercepts, because when we tried it, we got undefined. And now we can look for our horizontal asymptotes. Now the horizontal asymptotes are not the zeros like we had the vertical asymptotes where the zeros are the denominator. For the horizontal asymptote, you have to compare the degree of the top, compare it to the degree of the bottom of your rational function. Well, the degree of the top of this rational function is equal to 2. The degree of the bottom was equal to 2. So we have equality here for the degrees, and that means that the following equation, y equals lead coefficient of the top over the lead coefficient of the bottom, that's going to be the equation that represents our horizontal asymptote. Okay, so that would be y equals the lead coefficient of the top, the number multiplying the highest power on the top. The highest power x is the one number coefficient 1, and on the bottom it's 2. So we have the equation y equals 2. And by the way, this is y equals c, in case you want to know what c is. It's the number that y is equal to that represents the horizontal asymptote. And we will continue this graph, this sketch, on the next video.